Good morning, everyone. I am Dr. Vijay Babu. Today, I am going to discuss the topic of instructions and addressing modes. The contents of today's discussion is, first of all, we start with the introduction, and then instruction formats, and then we'll try to understand the meaning of addressing mode, and finally we will see various types of addressing modes. Let us start with the introduction. Normally, human beings have a tool called language to communicate among themselves. So that language can be verbal language or non-verbal language. But that language also has a vocabulary for effective communication. Similarly, just like the human beings, the way they communicate with each other, computing machines also needs a language called programming language for communication and interface with the human beings. So this task can be achieved by various programming languages in the form of high level, low level, and assembly programming languages. So programming language is normally built with a set of instructions. Just like the human language, whether for example a verbal language or non-verbal language, is made up of various letters, alphabets, and of course other grammar. So here, in case of programming languages, they are normally made of with a special kind of activities, a special kind of grammar called as instructions. So instructions can be viewed as the words of a computer language, and the vocabulary of the language is nothing but the instruction set. Let us define formally what is an instruction, and then instruction set, and then instruction format. Instruction. It is a sequence of various operations and micro operations that can be done on the data to perform a task. A sequence of operations and micro operations. For example, if you want to add two numbers A and B, you are going to write A plus B. A plus B. So that means here A and B are actually called as the operands or the data, and here this particular activity, this particular operation is denoted by this addition, is denoted by the operation. This is called as operation. This is called as operation. So normally a sequence of this kind of operations and micro operations is nothing but the instruction. Remember, each instruction needs to specify the data on which the operation needs to be performed. Each instruction needs to specify the data on which the operation is to be performed. For example, here we have seen A plus B. In this A plus B, A and B are actually called as the data or the operands, and this one is called as, this addition is called as the operation. Now, instruction set. Normally, to do a particular task, to complete a particular task, a single instruction is not sufficient. You require a set of instructions to complete that particular task. So for that we need a set of instructions. So that's nothing but instruction set. So here instruction set means a set of instructions needed to perform that particular task. You cannot expect always to perform tasks in the form of single instructions. For example, here A plus B is a single instruction. So this addition is a task and it is completed by means of a single instruction. But computers performs or computers executes tasks which are complex in nature and they will be executed or solved by means of a group of instructions or set of instructions. So that is called as instruction set, a set of instructions needed to perform the task. And next one is instruction format. A computer instruction is having a special format. It is having a special format. So it is also called as instruction code, and it consists of the code word that represents an operation called opcode and the address of that instruction present in the memory. Normally, an instruction, a computer instruction consists of various important parts. So that is defined by this instruction format. The first part of instruction format is the code of that particular operation, code of operation. We call it as opcode or operation code. The next important part of the instruction format is the address. It is the address. That means in which location of the memory that particular operand or data is going to be available in memory. That is, it can be in memory or sometimes in register. So these are the two important parts of instruction format. Now let us consider a 16-bit computer. Let us consider a 16-bit computer. Of course, these days we are working on a better, that means even higher bit computers, but let us consider we are working on a 16-bit computer. So for a 16-bit computer, the size of instruction is 16 bits. The size of every instruction is 16 bits, and it consists of these two important parts. These two important, for example, the first part, as I told you, consists of the code of that particular operation. We call it as opcode or operation code. Opcode. We call it as opcode. And it occupies from bit 12 to 15. Similarly, the address, the second part is actually called as the address part. Address part means it is the location in the memory where that particular data or operand is available or present. So this is address field part and opcode field part. That means every instruction format consists of two important fields. One is opcode field, second one is address field. Now, before we try to understand the meaning of addressing mode, let us try to have some idea about the address, because this is the word we frequently come across. This is the concept we frequently come across in almost all the concepts of computer organization. So let us try to have some idea, some clarity about the address. What is address? So address is a hexadecimal number. Address is a hexadecimal number that represents the location or presence of that data or operand and the instructions in the memory. So address is nothing but the location where those operands or the instructions are present in the memory. For example, if you consider this diagram, here various address locations are mentioned. You can see starting from here 1958, 1959, and then 195A, 195C, and so on. You can see this. See, all these locations are numbered, are identified by means of hexadecimal numbers. I repeat once again, the address locations in a memory or in a computer memory are identified or denoted by hexadecimal numbers. Now, let us try to have some more clarity about the address. We all know that in simple C programming language, we have the concept of declaration of variable, a variable declaration, and also how the memory is accessed and of course occupied with the help of address variable in pointers. Now let us see this. In the first case, the memory address 1001. The memory address 1001 is a variable which holds the data 900, and in C language normally we declare like this: int distance is equals to 900. Int distance is equals to 900. And here, what's the meaning of this particular declaration? Int distance 900, that means 900 is the data, and that data is stored in a memory location of 1001. Okay. Now, if you look at the other declaration here, int p, as this p is equals to and distance. So here you can see int is a type of data, that is 900, stored at memory address 1001, and to which the pointer p points to the actual location, that is this one 3366. So the memory address 3366 consists of another memory, that is 1001. So this is where the pointer concept comes into picture. A memory address which is pointing to another memory. Now another important address that we come across while dealing with the concepts of computer organization, especially while discussing the addressing modes, is effective address. What is this effective address? Effective address, in simple words, we can say that effective address is the final and destination address. Final and destination address where the operand or the data is available or present. Final or destination address, or final or destination location. In other words, final or destination location where that particular data is available. So that final destination can be in the form of memory, main memory, or sometimes in the registers also you can find. So that is the effective address. Let us try to know something about addressing mode. What is this addressing mode? So addressing mode is a mechanism of locating or finding the address of the operands. That means the location of the operands and instructions by the processor or CPU in the memory, that is RAM, or the other parts where the operands are stored. That means the operands or the data or instructions normally be stored in the memory, that is RAM. Sometimes the data also may be available or stored in registers. So how to locate those data, how to locate those instructions or operands? So the mechanism of locating or identifying or tracking, we can say something like tracking. So the tracking of those operands and data in the memory or sometimes maybe in the registers is called as addressing mode. So addressing mode is nothing but a method or a way of locating that particular operand. Now if you look at this diagram, this is the simple block diagram of a digital computer, that is von Neumann architecture. We call it as von Neumann architecture. So in this von Neumann architecture block diagram of digital computer, we have the CPU or the processor, normally we also call it as processor, this central processing unit, which is actually a combination of ALU and control unit, arithmetic and logic unit and control unit. And here we have the main memory or RAM. RAM is also called as main memory normally. and we have the input output devices, and it is the IOP processor which synchronizes all these parts, especially the IO devices. Now, to understand the addressing mode, let us consider these two things. First of all, CPU as well as the memory. Normally, the data or the instructions are stored inside this particular RAM or main memory. Now, if the CPU wants to add or to do any task, for example, if the CPU wants to add two numbers A and B, then where that A and B operands are located. That means the CPU needs those two data operands, that is A and B, to perform addition, because only inside the ALU that addition is performed. So, those data or operands needs to be brought into the ALU unit to perform addition. But how does the CPU knows where that A and B are stored? Normally, that A and B may be located or may be stored in this particular memory or RAM. So, the CPU needs to access, or the CPU needs to know the location of this A and B, where that A and B are actually present in this particular RAM or main memory. That means the CPU or the processor needs to know the address of this A and B. Only this address of A and B are known, then only the CPU can brought, or this A and B variables can be brought inside the CPU, that is inside the ALU, and can do the addition or any other operation. So, here comes the concept of addressing mode. So, there are various ways of locating or knowing the addresses of A and B present in this particular RAM or memory. Different ways are there. So, all those different ways are actually called as different addressing modes. Just now I told you, an addressing mode is nothing but a way or a mechanism of locating or identifying or tracing the location of or the presence of a particular data or variable. So, this is how the addressing mode concept works. So, sometimes this A and B may be available in the memory, sometimes those variables may be available, those data or operands may be available inside the register unit, inside the register unit present inside the CPU or processor, or sometimes they may be present somewhere else. So, CPU needs a proper way or mechanism to locate or to identify those variables, those operands or data. Now, let us try to know or try to understand various popularly used addressing modes. We have a set of addressing modes. We start with the immediate addressing mode, and we have the direct addressing mode, indirect addressing mode, register addressing mode, register indirect, displacement, and stack. So, the CPU may need to follow any of these addressing modes. It can follow any of these addressing modes depending upon the location of that particular data or operands. Suppose if the particular data is directly available in a particular register or register set, then it may use register addressing mode to locate that particular data or operand. So, let us start with immediate addressing mode. Let us try to understand immediate addressing mode. Before we see that immediate addressing mode or other addressing modes, there are certain notations used, standard notations used in this particular addressing modes, all the addressing modes. For example, A means the contents of an address field in the instruction format that refers to a memory, and R, the contents of an address field in the instruction that refers to a register. And we have EA that is effective address of the location containing the referenced operand. And finally, a variable X, which is placed in parenthesis, So that indicates the contents of the location of X, Let us start with the first one, immediate addressing mode. This is the simple addressing mode where CPU doesn't make any references. For example, immediate addressing mode means the data or operand is present in the address field of the instruction itself, in the address field of the instruction format itself. For example, let us say a simple instruction, move AL, 35. So that means move the data 35H into AL register. So the meaning of this instruction is the data of 35H is moved into, that is, let us say AL, or the data 35 hexadecimal. The data 35H is moved into the AL register. Immediate addressing mode means here itself, in the address field itself, the operand is available. So this is actually the address field. So the operand is directly available in this address field. So that means the CPU need not search too much for this particular operand, because within the instruction itself this operand is available. So that's why it is called as immediate addressing mode. That means the operand is immediately available in the instruction itself, in the address field itself. Next one is direct addressing mode. In direct addressing mode, the address field contains the address of the operand. That means the operand is not available directly, unlike the previous immediate addressing mode. Instead of that, the address of that operand is available. For example, if you look at this diagram, this is the instruction format, as we all know. Instruction format which consists of two fields, opcode field and the address field. In immediate addressing mode, we have seen directly operand is present in the address field. Directly the operand is present in this address field. But now in direct addressing mode, the operand is not available in the address field. Instead, the address of that operand is available. That means the address where that memory location is in that particular operand is available. For example, here you can see 4567. Let us say this is 4567 is the address of this particular memory location of this operand. So here we are going to have 4567. That means the address of this operand is 4567 and it is directly present in this particular address field. This is what is called as direct addressing mode. Instead of having that operand directly, the address of that operand is available. That is 4567 in this particular case. Next one is indirect addressing mode. In this indirect addressing mode, if you look at the diagram, the address field consists of the address of the first reference and then the second reference. That means, let us say this is our address of the actual operand, that is 4567, let us suppose. Now this is another location, let us say 4500. 4500 is the location of this particular location. So here it consists of 4500. So that means if you go to 4500 and from 4500 you are going to have another reference, and that is 4567, and here you are going to have your operand. Here you are going to find that particular data. So you are supposed to make two references now. So the data or operand A is not directly available, it is indirectly available. So you are supposed to refer two memory locations now. So this is called as indirect addressing mode or indirect addressing mode mechanism. Next, register addressing. In register addressing diagram, instead of memory or RAM, the reference location will be register. You don't find memory now. Now everything is referred with respect to registers. So registers are present inside the CPU. I told you already, the data or operands may be present in the memory or RAM, or sometimes available or present in the registers also. So if the data is present in the registers, then that is called as register addressing mode. Now let us see how this addressing is done. So register address. In the address field, this is the address field. In the address field, the address of that particular location of the register is actually presented. For example, here it is something like 4567. So this is 4567, something like this. So here in 4567 we are going to have the actual location of that particular operand or data A. So instead of memory, as in the case of other previous modes, addressing modes, now you are going to refer the registers. That means the CPU is going to locate the registers locations to find this particular operand A. Next, register indirect. Register indirect means it is once again two references. For example, let us consider this is our actual instruction format that consists of two fields. One is opcode field and the address field. And initially the register address is the first reference will be towards the register, and from register to memory, register to the memory location. So here we have the address of this register, and if you come to this particular register's address, it points to another address of memory. For example, let us say it is 4567. So this is 4567. So it is, let us say, something like 6932. So here 6932. That means if the CPU comes or refers this particular register location, it refers to another location 6932 to locate the actual operand A or actual data. So two references. So this is called as register indirect addressing. Next one is displacement addressing. In displacement addressing, you can see two references, just like in the case of the register indirect addressing or direct addressing. So you are going to have two references. For example, we have a displacement, address is going to be displaced. So it all starts here, the instruction set register R and the address A, register R, this is register A, register R. So this is the first reference, and then the address of that particular memory, that data present in the memory, so it is added. So these two together, if you add these two, you are going to get the actual location of that particular operand. This is the operand. So this is about the displacement addressing or displacement addressing mode. Stack addressing. Stack addressing, what happens is the operand is implicitly on the top of the stack, especially while doing operations on stack, while doing operations with respect to stack memory, then this particular addressing mode is popularly used. For example, add, we have the simple instruction add. So that means popping top two items from stack and add automatically. That means the location is top of the stack. If you say add means adding the top two items. That means popping the top two items from the stack and add. So the top two items of the stack, for example, this is the stack, this is the tag. So the top two items are popped and added. So this is called as stack addressing. So with this we have seen how the addressing modes will act, or how the CPU tries to find the location of operands or the data using the mechanism of addressing mode. And we have also seen the concept of instructions, instruction formats, and what are the fields, important fields of instruction formats, and so on. Thank you very much.